The 2006 Department of Energy MICROGRID report describes what will be the next generation for power distribution, and C3 already delivers this technology along with its numerous advantages for LED lighting. Almost 6 years ago, C3 Lighting developed a technology to remotely power and control LED lighting that creates a DC microgrid. As you all know, the global power system relies on the generation, transmission, and distribution of AC power through an electrical network often referred to as the power grid. There is an expanding use of direct DC power in commercial applications, whether converted from AC power or generated directly by solar or wind. Our remote power and control technology is important because of the increasing use of direct DC power. What is important for this seminar is the role that our remote power and control technology plays in the lighting industry. It provides an easy and extremely effective way to bring improved performance, advanced features, and control to the lighting market. All LED fixtures, office equipment, and personal electronics use DC power internally that is converted from AC power. Each time you convert from AC to DC power, you have an 18 to 27% energy loss. The fact that our technology converts AC to DC one time in a central location and then distributes the DC power for lighting provides added energy savings when compared to traditional LED fixtures that convert from AC to DC on every fixture. This technology eliminates a great deal of heat that is generated by AC to DC conversion from the occupied space. This allows fixtures to be thinner, lighter, and produce less heat than traditional fixtures because they contain no drivers or control modules. Fixtures can be located up to 250 feet in any direction from the power distribution module. With an onboard microprocessor and integration of lighting control in the power distribution module, we eliminate the need for redundant control modules on every fixture. This provides the ability to easily program and control lighting conditions and monitor energy usage from one location. The backbone of our system is our patented remote power and control technology. Our power distribution modules create a DC microgrid in a building or an area of a building. This microprocessor-controlled DC microgrid is used to distribute low-voltage DC power to LED fixtures, serves as a hub for control and sensor input, can power office and personal electronics, interfaces directly with building management systems via BACnet. An important feature of our remote power and control technology is that it can be either manually switched or programmed to switch from AC to solar, wind, or battery-stored power. These alternate energy systems generate DC power, which is converted to AC power and then converted back again to DC power to be used in office and personal electronic equipment. The result is a 36 to 54% power loss. Our DC microgrid technology eliminates multiple power conversions and saves an extreme amount of energy, whether for lighting or other electronic uses. C3 does not look at lighting as fixtures and switches, but views lighting as a digital illumination system consisting of power, sensors, fixtures, and controls with color changing, energy monitoring, and programming capability, all interfacing with a building management system. In other words, a digital network where the LED is just one component in that network. This is the future of lighting, and C3 has it today. A single power distribution module can control up to 48 2-foot by 2-foot fixtures, or as many as 192 6-inch round downlights. 21 power distribution modules can communicate with each other by Cat5e cable to power and control up to 512 channels or zones of lighting, and up to 50,000 watts of 24-volt DC power. Digital wall controls can be easily connected in series or directly to the power distribution module with Cat5e cable and communicate via 0 to 10 volt DC or DMX 512 control. Daylight harvesting and occupancy sensors can connect to our wall controls or directly to power distribution modules. Our power distribution modules can be controlled by wall switches, touchpads, computers, iPads or iPhones, and can communicate via BACnet to a building management system. Before moving on, let's briefly emphasize just a few of the features and benefits of our remote power and control technology. Heat is located outside the occupied space. and our fixtures operate at only 7 degrees above ambient temperature. There is no RF or EM interference in the occupied space. This is important in certain specialized applications and is becoming a concern in many more areas of a building. Remote power and control technology allows emergency battery backups to be removed from fixtures and located outside the occupied space, which greatly simplifies and reduces the cost of emergency lighting, system inspections, and maintenance. A centralized microprocessor provides total system control, advanced communications capability, 0 to 100% dimming, RGBW color control, clock calendar programmed lighting scenes, a BACnet interface, and reduced maintenance costs. In today's world, energy efficiency and green standards are an important part of life, and C3 Lighting takes our role in this global initiative very seriously. Our low voltage system uses inherently safe 24-volt DC Class 2 wiring, which utilizes smaller gauge and less wire, and in most commercial installations does not require metal conduit. This greatly reduces the carbon footprint of our installed system. In addition, all of our products use non-ferrous materials and are 99% recyclable at end of life. Okay, these next two topics are the big game changers. You may have noticed the buzzwords in the lighting community right now are tunable white and dawn to dusk lighting. Tunable white is a technology that enables users to adjust the color temperature of lighting, and dawn to dusk lighting is designed to simulate sunrise to sunset indoors. You have probably already been asked to quote on projects requiring tunable white light, and these requests are only going to increase. Soon it will be a standard in many environments. A few tunable white products are on the market, but the ability to easily and effectively control their light output is missing. C3 has a full range of tunable white products and a practical solution to control the level and color of light output. Another promising area of research centers around the effects of light on the human circadian system. Around the year 2000, photosensitive retinal ganglion cells were discovered in the human eye. There is currently a substantial amount of study being conducted in regards to the effects of light on these IPRG cells, which influence melatonin and other chemical levels that affect the human biosystem. This process is largely tied to the presence or absence of blue light, predominantly around 480 nanometers. Stated very simply, certain color temperatures of light through this cellular pathway have been shown to affect mood, energy level, test scores, reading speed, hyperactivity, and numerous other biological conditions. C3 offers a line of dawn to dusk lighting products that use amber 590 nanometer, blue 680 nanometer, and two proprietary white LEDs to provide a soft amber sunrise, blue-white midday sun, and a slow warm sunset. This effect can be programmed to meet the end user's requirements and provide a lighting environment that may be used to affect human circadian rhythm. Early research shows that in specialized applications, this illumination technology could be beneficial to the human biocentric system.